but you're sort of expected to be conversant in the tools that are available, so when someone says, give me the process dump, you can actually do it. Now, anyhow, OS2, when it has a problem, does one of two things, depending on where the problem occurs. If one of your, what we call Ring 3 applications, things like Firefox or your editor or whatever has a problem, you will get an exception. And you get a couple types of exception reports are available. So one is just standard old process exception, and usually you'll see it in your pop-up log, or if you're unlucky, you'll see it at the command line. If you're using GCC. And then the other one, which we don't like to see we don't see too often anymore, and we really don't like to see it at all. That's the kernel. When the kernel gets a problem that it doesn't know how to get out of, it just says, I'm dead. And the assumption is this is IBM's way. Rather than trying to just go on, it says, well, I might destroy data if I go on. So it's really better if I just give up and maybe destroy data that way. Well, you know, you're never sure. Now the other place, let me get this out of here. Whoops, not that far. Now there's a bunch of other exception reports you'll get, which are typically generated by applications. Okay. One is excepq, which we'll talk a little more about later because they're getting pretty pervasive and they're almost human readable. Developers don't have any trouble. Some end users can read them. But then there's also GCC libc exception report. Those are the ones that if you're running a command line application, they come out of the command line and say, you should really be running a process dump now. Now, if you're running a GUI app, you don't see anything. You just know your app stopped. That's the case where, for instance, if you're running Firefox, a lot of times they'll tell you to use run with logging, so that at least you can see the exception report. This is in the old days. These days, Firefox has full excepq report, so it's not as needed. But excepq, because of the way IBM implements exception handling, excepq cannot always run. The application needs enough stats so that basically OS2 can call the exception handler and let it process. And if it doesn't have enough stack for that, then you'll fall back to the pop-up log, or in the case of GCC, you won't see anything. Then another thing we use a lot is at the workplace. You know, it's there, it's usually unnoticeable, but it's there and making your screen and making your desktop look better. But every now and then you may hear a beep. And that usually means you should go look at your excepq log. Or not, excuse me, your eWorkplace log. I think of them interchangeably because it's almost the same code that's sort of forked out. If you look at the eWorkplace log, you'll see all the same similar data items because it all came through the original IBM written excepq code. And then we don't have this one too much anymore because we're not using it as much. But the Initech font library has its own exception handler too. So if all of a sudden your desktop hangs up and it looks like a font problem, go hunt down the log. Now I'll talk about a little bit more about where to go look for these things later. Oh, another thing that I should mention, exceptions are not really always fatal. IBM has this interesting thing they call even things that are realistically just notices, exceptions. And it happens to us programmers too. They have a whole bunch of things that are under the error class, DOS error this, DOS error that, and they're not. There's simply notices that something happened. And usually it takes a while to understand that, but I've had guys say, well, I'm getting this exception. It doesn't matter. It's just a notice. It's not an error. And what should have happened is the application should have never reported it. So it's actually, when those things show up, it's an application reporting error. Or a user error, like in the case what Greg was mentioning, where he was getting excepq reports because the application exited normally. Because there are cases where you actually want excepq to do that. And I'll talk about that a little more later, but in general you don't. And Excuse me one sec. Let me get my pointer.
Is it red?
So your standard process exception report generated by the kernel is that. It'll show up in your pop-up log. This is all nicely documented in the debugging, in the OS2 debugging guide, which you all have as part of your ECS distributions. And if not, you know, it's downloadable in a number of places. But basically, it's just telling you who died, the type of error. And this is important. That's actually an error. But if you see something like a C101 or something like that, that's not an error. That's a notice. Unless it shouldn't happen. Well, one of the things we have every now and then when we're doing ported applications, like the last one I think was Apache, and programmers would very nicely stick an exit statement in the case where they got confused and didn't know what to do next. And of course, things would shut down without any logging, no messages, no nothing, which was the incentive for actually putting the G option in exception. Because then I did get reports with the C101, and we said, oh, that's where it left from. And then we took that code out, and we could do something else, and no longer silent, more silent exits. Now, this is the bad boy here. You get one of those, it's time to reboot, check disk, and hope your drive is still okay. Fortunately, you know, unless you're really doing a lot of intensive disk activity, you usually survive that check disk. But what you're seeing here is that's where the error occurred. What happens is people tend to, instead of writing all this down because they didn't have a camera or they forgot to use it, they write down this, which is useless. Don't send me that. I will chide you or ignore you, one or the other. Because this is actually just the place where it stopped in the kernel, which has absolutely nothing to do with what actually caused the problem. There's about 5 or 6 of these places in the kernel, and it says, oh, okay, I got to stop there. This number is actually useful, but there is no cross-reference. There are ways to look it up, but it's not as much fun as you might think. What it really represents is a module name and a line number. And these are, IBM has a cross-reference to this, and they won't give it to us. And they won't give us the source either, so I don't know the line numbers.
Yeah.
But the benefit is you've got to disassemble. If you have the kernel in the kernel debugger or something like that, you can go searching for that stuff. Because this stuff here is usually close to that address, just because of the way the thing calls it. For those of you who are familiar with IBM stuff, it's sort of like an old mallard. Pushes the values on the into registers and it just jumps. Or it does the other one where it does the call and the data follows it. Except exception reports. I didn't bother putting an example in here, but I gotta believe every one of you have seen at least 2. And if you haven't, I don't know what program you're running these days. But what they basically are is you take what you would normally, as a programmer, grab out of a process dump to get your basic debugging information, your registers, some memory dumps, and all that sort of stuff. And you just put it out in a nice readable, printable format, formats that you normally need it in. Like for most of us when we're debugging, we need 32-bit values, and we also need character values. These days, because we're not doing too much 16-bit code, we don't need the 16-bit values. Now we can get them if you want them, but the thing is, just in general, and also what we do is we dump the areas that our registers point to, which are typically the blocks that were in use at the time when the problem occurred. So if you're lucky, you'll have non-gibberish data that you're pointing to that will tell you what's wrong. And it helps a lot. Plus, you also get a combination of a stacked trace, which tells you who called when to who. Because often, if you pass bad pointers, any of you who programmed have seen the trap happens in the string copy, not in the guy who passed the bad value. And so, but with the stack dump, you'll be able to find out who actually started the problem. And sometimes, though, unfortunately, because of the nature of how PC instruction set is, they don't always give us what we call stack frames, so you can't trace them. So we do a secondary dump where we just find things that look like labels on the screen. And those of you who have sent me things without that nice little listing and that bad trace thing, you get the standard response, install the symbols. So that I don't have to do that decode by hand, because I'm lazy. That's why we've got the code. But the end result there is why you can basically read between the lines and decide which of these labels you're seeing are really the ones that matter. Because sometimes the labels appear just because it's a random number at this point in time. It's something left over or something like that. But it's all information that's easier to handle than starting with the process dump and doing all the decode by hand. Okay, GCC exception report looks a lot like a process dump exception report, except much worse. Because the problem is he left out a couple things that I always need. And maybe the next version of KLibC will add that in if we remember. I think I got a ticket in for it. But it's just missing stuff here. And I don't, it's odd. I just don't understand why Duke did that. Because it's not his style at all. But for anybody who's not a programmer, this stuff is meaningless. But even if you're just a C programmer, you see enough of it and you figure out how to use it eventually. eWorkplace, okay, they get written to either EWTrap.log or XWTrap.log. How many of you just use XWorkplace and overwrite eWorkplace? For you folks, it's all XW this, XW that. Everybody else, they want EWs. And this is what I was saying before. These two really share similar parentage. And it should go to your log directory. Or if it has trouble for some reason writing to the log directory, it'll go to your root. And there's usually a beat that goes along with it. This one here, yeah, that goes to the root of your boot drive, and you won't see too many of them anymore. Back in the earlier Mozilla builds, we made extensive use of this library, so we got good anti-aliasing. But Firefox is now based on something we call the Cairo libraries, and we just don't use this anymore. And Lars actually wrote an application to get rid of it so that nobody would use it when they shouldn't be. And the folks that are still using it haven't found Lars' tool yet. Now, the one downside of a dump is it's static. And also, depending on the type of trap you have, it may happen too late. The data that actually caused the trap and the problem that actually caused it may have happened long ago, far, far away. Now, for that, you need other tools. One of them that helps sometimes is tracing. And there's a number of them. One's the OS2 trace facility. And that is built into the kernel, and it's extensible to a point, and it works. For some reason, typical for IBM, it's not fixed. There's just places where they claim they have trace points and they're not there anymore. And there are ones that don't. And the only reason I know it is because they're ones I actually wanted sometimes. And what it's turned out to be helpful, though, because over time we put tracing support into the various drivers that need it. Because the other problem is you got a driver that's doing a whole bunch of stuff, and it doesn't do it right. how do you know? You know that it's not transmitting buffers, but unless you can actually see the sequence, what happened, it's hard to infer what really went wrong. Now, if you're in the kernel debugger, you just step it through and all that. And that works okay, except when your problem is timing related. And for that, trace helps. I know Lars has made good use of that with his stuff, just found problems that are just hard to find otherwise.
Now, when you tell us to trace in a driver, you'll give us some magic sort of number. Trace, and then give us a number for this driver or a number for that driver. Is there any directory of what those numbers might be?
Yes.
Okay.
IBM, those are user-defined though. The directory is in the README that it gives you. But for all the other ones,
Yes.
the system trace, those are documented in the os2trace.ipf. Now, bad news is IBM, for some ungodly reason, when they did MCP, took all the good information out of that IPF.
Oh.
And so they just give you how to run the thing, and I don't know, and there's a couple README text files for the other ones. If anybody needs it, I have guides that I've compiled over the time that have what I consider as complete as what I know is complete. Plus, I keep copies of the Warp 4 one around because it's searchable and all that sort of stuff.
Okay.
Another tool is OS2 Trace and PM Spy. Let me go down here a little bit. So a little more back up here with a little more detail. So anyhow, I mentioned these guys are available for me. They're on my site. For those of you who don't know where my site is, it's home.earthlink.net/Steve53 and then hunt around. And I also have an alias from www.warpcave.com for that too, which will find me. And of course, I'm always available by email. Some of this stuff will be moving to a better site someday when I get around to it. Unlike some of you, I can do web work just fine. I just don't do it. I find other things to do first.
Good enough.
Yeah. And let's see, what else? And I keep saying that these two trace points, this has been in here for years, and I still haven't rebuilt the TDF files to no-op them out. But no one uses, if someone tells me I tried to use this trace point and failed, then I'll fix it. Sort of like an Indeed thing. Because I know not to enable it. And that's why IBM didn't fix it. It wasn't on the top of their list. And I have a little tool that basically makes it easier. Because one of the things I will say about OS2 Trace is for anything resembling, except the simplest uses, it is a pain in the butt with the command line. These are easy. It's like OS2 Trace on 16 or something like that, or 23, whatever it is. But for anything else, when you need individual trace points, it's bad. So I basically put a little wrapper on there that goes on and does turns on the formatter, turns on the trace with the standard size, and reads a config file which has the trace commands in it. And I give you lots of examples so you can cut and paste and all that sort of stuff. Because the examples in the trace reference are not really human readable. They're readable, but you actually have to know what you're looking at, and why you're looking at it to be able to use it. So. Okay. Now the OS2 trace is done by a guy by the name of OS2 Black. And basically what he did is, okay, let me tell you why the downside is. This one, the good side is it's much more complete. The downside is that it's intrusive. It modifies your program. Which is not a bad thing. You just take a copy, and let it modify. And it'll actually unmodify it too, but what I do for safety is I just take a copy, back up anything I'm going to let it modify. And what he has done is he has good, very nicely human-readable decode of every API. Basically, he's got the forwarders for everything. For those of the programmers that understand, wondering how they do this. And it's easy to use. I have a little GUI. It has a GUI setup wrapper, which is pretty easy to use. You just say, oh, well, turn on tracing for this executable or this DLL. And then you have a lot of control over which items that you want to do it. If you need command line stuff, there's a command line tool for it too. And it does, the only The limitation it has is I've had some trouble with 16-bit applications. Because it's a 32-bit application, it wants a bit more stack than some 16-bit applications have. So it'll blow up. But for 32-bit apps, I've had no trouble with them all. And you get these nice logicers, easy to read trace files, which are controllable if they don't, so they have what you need in them. And you can get it at Hobbs, and it's also available at Dave's homepage. And what I'll do with this thing is we'll put this up, and these links should all work right. And I'll go through it again and make sure. They're good the last time I looked. Now, for those of you doing GUI work, and you're having windowing problems, what you may need to use is PM-Spy. PM-Spy basically does a really rough trace of your GUI activity. Message, data 1, data 2, so on and so forth. And with window message, data 1, data 2. A lot of hand decode, but good control in terms of what you want to see. So if your things that windows aren't drawing and stuff like that, usually that's good enough to figure out why. So you can figure out who's sucking up the message and not letting it go on. Or at least you can see which messages get lost and then go from there. But it's definitely a programmer tool for interpretation. Easy enough, easy for the end user to use. If you can tell, you just tell them, okay, turn on these messages, turn off these messages, or send them a new file. But definitely not something that somebody who doesn't understand GUI programming can be able to read. And it's on Ian's OS2 site and other places. Now, sometimes you can get by with, you don't need this full real-time tracing. All you need to do is be able to see what happened over time, and that's logging. Typically, logging just grabs events of interest and writes them to a file. You'll see that in a lot of apps such as System Error Log, which is built into OS2. Mozilla has a log facility which doesn't need as much use as it used to need, but it's there if you need it. And it's very, very complex and very, very configurable because Mozilla's a huge app, so it's got tons and tons of opportunity to write data. eWorkplace has logging. KLibC has logging. But you have to use a logging DLL for that. It's not built into the standard DLLs. TCP/IP has a syslog facility. Now that's application dependent. And then Initech Font Library actually has a log too. But again, less use for that these days than in the past. System log entry, I view them as like a mini process dump. But they're just, the problem is it's one of these good ideas that IBM never really documented well externally. There's actually quite a number of apps that use it, but finding out what they're actually using and also making sure that and having them actually use the current version is sometimes harder. So it's, it's there. I mentioned it because it exists as part of the kernel, but I don't use it a lot.
What's the system error log data?
Oops, where's that?
Yeah, where's the data file? If someone says, I
in,
blew up, and I say, mail me your system error log, what file do I tell them to mail?
Oh, it's in OS2 system. RAS.
Okay.
Yeah, it's those.
Normally you can put it anywhere, but by default it's there.
Yeah, they won't have moved it. Okay.
Yeah.
Yeah.
And of course you can use, if you're lucky, PMDF will format it for you.
Okay.
Because PMDF is one of its not well documented features is it does read those dumps.
Yeah.
Sometimes. I haven't figured out whether that's a PMDF bug or end user bug, but I think it's just one of these things. It's just not really fully stabilized. It works for the apps where it works for, and they needed it, and so on and so forth.
Okay.
But the thing is, the nice thing about it is that it is there. You don't have to write your own log file IO and all that sort of stuff. And the document, it's there. The documentation's there, but it's reference documentation, not tutorial documentation. Mozilla log facility. Hopefully none of you will need it. It's just good to know that it's there, so if anybody tells you you've got a problem, say, well, turn on the Mozilla log and do this and this and this. You know, you'll know what they mean. This you'll get automatically. They'll go to your EWP log directory, and for some reason they're written to the temp directory. One of these days I actually have to put a ticket in to ask to get them moved to the logs directory. But this was written long before we had log directories. And I'm not sure why the change was made to the xwtrap.log, where it does go to the log directory. Although I think log is the wrong name, because I think we use log files. Because I don't think we have a log directory, do we?
Bar log.
Well, that's bar log. I'm talking about the environment variable.
Oh,
Yeah,
When I said
it is
those
the
are
environment
logs,
variable.
yeah. So I think that's out of sync too, but if I ever mention it to Paul, it'll probably get fixed. KLive C-log, again, use their DLL, and there's no control. You get everything, and it's huge. But if you have an easily reproducible test case, it can be handy. TCP/IP system log, that is just standard in every TCP/IP stack out there. And most applications that are network related, TCP/IP network related, will write to it. It's just, if you're writing TCP/IP apps, you use the syslog. This is there. And we have the IBM version. I prefer the syslog v3a. It's just easier to use, and it seems to be more configurable. And that's pretty much it for that. The log, and the other benefit of the log files, they can go anywhere. So if you have this, sometimes they can get pretty big, but it really depends on the application. Like if you're using syslog on Apache, you can get large. Intertect font live, I just simply mention it because it's there. The logging wrench key, and you've got to use wrench edit 2 to turn it on. But I doubt very much anybody, at this point in time, anybody's ever going to ask you to turn it on again. Okay, a little more on a process dump. One of the problems we have with our pop-up logs is, again, it's like everything else. It's the point in time when you trapped, which may or may not have any relation to when you really had the problem. And sometimes accept queue is not enough, so we'll need a process dump. And the person who's helping, I have wrappers to get it set up, but typically, if you're not a programmer, you need the program to interpret it. They'll help you with it. It's easy to set up. You just say, turn it on, know where the dump files go, and then make the trap happen.
You have dump process or pdump user, you're saying happens on exception, but can you just say, I want to dump right now? I don't know
Oh, yeah,
what we're
yeah.
doing with this.
Yeah,
Do you need
yeah.
it right now?
Process,
Okay.
the command-line process dump CLI has that ability.
Okay.
And this thing here will wrap that for you. It gives you a little menu.
Okay.
Yeah. If we have time later, I can show you some of these things in action. Trap dump facility, same problem. Sometimes, well, actually, not really the same problem. This is almost invariably the place when you get a IPE and you take the picture of the screen, or if you have, that's not enough. You really need a trap dump to figure out what's going on. And it's the same thing. Trap dump reference to set it up in config sys, or set it up in command line, which is the preferred way. If you're not getting the dump at startup, there's no sense having trap dump set up or even process dump running in your config sys. Because otherwise you probably will forget it's there and fill your disk up with files for little programs that's dumped every now and then. And this is an old thing for those of you who still have a floppy disk on your system. Way back when, what happened is,
Yeah.
before we
Control
had-
Alt,
yeah.
Control Alt, number lock. Always wants the floppy.
right, even if you don't have one.
Exactly.
Well, what he wants a real mode program. It's not going to check for the floppy. It doesn't have enough space. But back in the days, before we had enough disks to do trap dumps, because it used to be, there was a time when, your disks were full, and actually finding a place to have a partition for the trap dump was hard. But not so much anymore. Now it's just the hardware is giving us fixed, so we can't get the trap dump when we want them. But eventually it'll get fixed. But what dump trap screen did is it basically read that first diskette and found the trap screens in it. And it was, but today everybody has a camera. So now what I get is I get these cameras which are these pictures that are totally keystoned, which I can't run through OCR.
Yeah.
And I go, could you put a tripod on that thing and focus it? And it's even better than that, I get this wonderful background, this tiny little screen.
Yeah.
And you run it through Emboss 2 trying to clean it up, and you end up, it's just faster to write it down by hand.
Yeah.
Or keep the picture. But there are some, sometimes for known problems, those trap screens actually are useful. For instance, for those of you that had video problems that would get the trap where it would try to go to the 32-bit PCI BIOS that wasn't there. We recognize that one immediately. And we just say, no, you have to run ACPI on this system. So ACPI replaces the missing BIOS code.
Oh, okay.
So you don't trap anymore. And you have video. It's a good thing. Okay, now once you've got these dump files that we keep talking about, you've got to be able to read them, because they're just some ungodly binary format, which is really hard to read. And the reason I know it's hard to read is because PMDF can't read it half the time. It's just, an interesting format, but they did what they did. And basically create PMDF, reads them in, and then gives you an interface that is a combination of extended menu options and something that's the same commands you would use for the kernel debugger. It'll do some of the search stuff to find labels on the stack and all that. And it's generally an indispensable tool for looking at static dumps. And there's no replacement. It makes it indispensable. Now, there's a bunch of other little things that IBM has thrown in over the years that advertise to some level or not, which are very handy. One of the ones I've very often mentioned to people is Thesus. Thesus is for figuring out what's going on with your memory and what's loaded and how much of this and that you're using when it comes to memory resources. If you're running out of memory, and all of a sudden your system says, I have no shared memory, you want to figure out how. Thesus answer that question pretty easily. It's got linear memory usage screen, which is readable, and you just go down the columns and find out who it is. Fix is not necessarily easy, but you can't fix something until you know what the problem is.
It also has a disassembler.
Pardon?
It also has a disassembler, which really
Yeah, that's handy too.
really helpful.
Yeah.
You want
Not
to
the
look at
best
those.
disassembler, but it's there and it's good. It's just another of those tools. PStat has been around forever. It just basically dumps your loaded executables and DLLs and a couple other things. And it's handy sometimes for finding what's loaded. I find these days I tend to use VS files and grep more often because I'm looking for specific things rather than an overview. If I want an overview, I go to Thesus because it just gives a much, much better picture of the whole thing.